Hello everyone, welcome to this session on Numpy array shape manipulation. In this lecture, we will learn how to change the shape of Numpy arrays without changing the actual data stored inside them. We will discuss various shape manipulation functions such as reshape of, flatten off, ravel off, transpose off, resize off, np dot, new access and squeeze off with suitable example. Let us begin by understanding what shape manipulation means. What is shape manipulation? Shape manipulation refers to changing the structure or dimension of an array without changing its data. NumPy provides several built-in functions to perform shape manipulation efficiently. Some of the commonly used functions are reshape of. It changes the dimension of an array. Then flatten off. It converts a multi-dimensional array into a one-dimensional array by creating a new copy. Then ravel off to convert an array into a one-dimensional array by creating a view. Then transpose off to interchange rows and column. Then resize off to modify the shape of the original array. Then for adding or removing dimension, we have two more functions. Np dot new axis, it will be adding a new dimension. Then squeeze off, it remove dimension whose size is 1. Now let us understand each function with an example one by one. First, we are going to understand reshape of. The reshape of function is used to change the shape of an array without changing its element. One important rule is that total number of elements must remain the same before and after reshaping. Let's understand this by using the following code. So here I am importing numpy module by using the statement import numpy as np. Then I am creating a single dimensional array by using the function np.arrayof and stored it in variable a. So this array will containing 6 elements. Then b equal to a dot reshape of 2 comma 3. In this statement we use the reshape of function. The original array a is reshaped into 2 rows and 3 columns. The reshaped array is stored in a variable b. Notice that the element remains same, only the arrangement changes. Then print b. So this statement displays the reshaped array. Important thing we have to note out here is before using reshape, always ensure that total number of elements remain unchanged. So here original array, it contains 6 elements. Then new shape, it has 2 rows and 3 columns. So this is also 6 elements. Since both are equal, so reshaping is successful here. Next we are going to see the function flatten off. Flatten off function, it convert a multi-dimensional array into a single dimensional array. Unlike ravel off, flatten off create completely new array. Therefore, it performs deep copy. Let us understand this by using the following code. So here I am creating two-dimensional array by using the function np.arrayof and stored it in variable a. So this array contain 2 row, 2 column. Then b equal to a dot flatten off. So the flatten off function convert two-dimensional array into a one-dimensional array. The converted array could be stored in b. Since flatten off create a new array, so b it has its own memory. Then print b. This statement prints the one-dimensional array stored in b. So one important thing we have to note here, the flatten off function return a deep copy. This means that if we modify the original array A, the array B will not be affected because both array occupy different memory locations. Next, we are going to see about ravel off. In the previous slide, we learned that flatten off create a new array by performing a deep copy. Now let us learn ravel. The ravel off function also converts a multi-dimensional array into a one-dimensional array. However, unlike flatten off, ravel off, it creates only a view of the original array. This means both array share the same memory. Therefore, any modification made to one array is reflected in the other. Let us understand this by using the following code. So here I am creating a two-dimensional numpy array by using the function np.array of and stored it in variable a. So this array has 2 rows and 2 columns. Then b equal to a dot ravel of. In this statement we use ravel of function. It converts two-dimensional array a into one-dimensional array. The result is stored in a variable b. Unlike flatten of, ravel of does not create a new copy. Instead, b become a view of a. So see here, after creating a view of a in b, I am changing the a 0, 0. That is first value, instead of 1, I am replacing it as 9. Then I am printing b. So since b shares the same memory as a, so this change is automatically reflected in b. So this was a shallow copy. So one important point noted here is the raveler function perform a shallow copy or view. Therefore, modification made to the original array are reflected in the raveled array. Next, we are going to discuss transpose of. The transpose of function, what it will do, it change the orientation of an array. It converts rows into column and column into rows. So this operation is commonly used in matrix operation and data processing. Let us understand this by using the following thing. So here I am creating a two-dimensional array by using the function np.array of and stored it in a variable a. So it has 2 rows and 3 columns. Then I am performing transpose by using a dot t. So dot t, the attribute perform the transpose operation. The transpose array is shown in the output here by using the print statement. So the see here, the rows become columns here. So one important thing we have to note it here is the transpose operation changes only the arrangement of rows and columns. The data value themselves remain unchanged. Next, we are going to see about resize of. So the resize of function which return a new shaped array. Resize directly modify the original array. So let us understand this by using the following thing. So here I am creating a single dimensional array by using the function np.array of, and I am stored this in a variable a. So this array contain 4 elements. Then a dot resize of 2, 2. So by using the resizing function, I am making this single dimensional array as 2-dimensional. This single dimensional 4 elements can be modified as 2 rows and 2 columns. So I am printing this here. So the original array is modified here. So the thing we have to note out here is resize of function modify the original array permanently. No separate array is created here. So next we are going to see about adding new dimension by using the function np.newAccess. Sometimes we need to increase the dimension of an array. Numpy provides np.newAccess. For this purpose, it allows us to convert a one-dimensional array into a row vector or a column vector. Let us understand this by using the following code. So here I am creating a single dimensional array by using the function np.array of and stored it in variable a. Then see here b equal to a of colon comma np.newAccess. So this np.newAccess inserts an additional dimension. So the expression colon comma np.newAccess, it convert one-dimensional array into a column vector. Then the result is stored in b. Then we were printing b, so it print the newly created two-dimensional array. So the thing we have to note it here is the data remains same, only the number of dimension changes. Next we are going to discuss about skews of function. So the skews of function, what it will do, it will remove dimension whose size is equal to 1. It helps simplify array that contain unnecessary dimension. Let us understand this by using the following thing. So initially I will be importing numpy module by using the statement import numpy as np. Then I am creating a three-dimensional array by using the function np.array of and stored it in variable arr. Then by using the print statement, I am printing the original array. Then I am printing the shape of original array. So the shape of original array, since it's a three-dimensional, so it has one block of two rows and three columns. Then I am using squeeze of function. So sq equal to np dot squeeze of arr. So here I am performing squeeze of function. So the squeeze of function, it remove all dimension whose size is 1. Then the resulting thing could be stored in sq. After this, I am printing the SQ. Then I am printing the shape after performing squeeze off. So see here, this three-dimensional will be converted as two-dimensional. And if I am printing the shape after squeeze operation, it shows that it will have two rows and three columns. So the thing we have to remember here is, that is, the unnecessary dimension have been removed and the array become a simple one-dimensional array. I hope you will be understanding better about NumPy array shape manipulation function. Thank you for watching.